Okay, welcome back. Today we are working on Chapter 2, Day 2 notes, other types of equations. So we will be working with some extraneous solutions. So extraneous solutions are just when you get a solution, but it's actually not a valid solution for the problem that we're working with. So it's important that we check to make sure our solutions are valid. So an extraneous solution is possible when we square both sides of the equation. So squaring both sides. And then it's also possible when we are multiplying both sides of the equation by the variable. And the way that we check if our solution is extraneous is we just substitute it back into the equation and see if the right-hand side equals the left-hand side. So our first practice problem, we have the square root of 6x minus 5 equals 25. So to solve this problem, we have 6x minus 5 is equal to 25, or we have 6x minus 5 is equal to negative 25. Okay, so I can just solve both sides. I'm going to have 6x is equal to 30, so x is equal to 5. For this other one, I have 6x is equal to negative 20, so x is equal to negative 20 over 6. If we simplify that, we get negative 10 thirds. So my solutions are x is equal to 5, comma, negative 10 over 3. Okay, I did not square both sides and I did not multiply both sides by the variable, so I don't need to check for an extraneous solution. Our next example, we have the square root of x plus 3 equals 2x minus 2. So for this one, I am going to square both sides of this equation. Okay, so since I'm going to be doing that, I want to make sure that I check at the end for extraneous. Okay. So if I'm squaring both sides, I'm going to have x squared plus 6x plus 9 is equal to 4x squared minus 8x plus 4. Okay, so let's move everything to one side. So we'll have 3x squared minus 14x minus 5 equals 0. Then we can go ahead and factor. So I have 3x plus 1, x minus 5 is equal to 0. 3x plus 1 equals 0. X minus 5 equals 0. Solve both for x. We have x equals negative 1/3 and x equals 5. So we do have to then go back and check for our extraneous solutions. Okay, so to check for our extraneous solutions, we're just going to substitute our solutions back into the original equation. So I have negative 1/3 plus 3 is equal to 2 times negative 1/3 minus 2. So on the left-hand side, I'm going to get 8 over 3 is equal to negative 2/3 minus 2. So I have 8 over 3 is equal to negative 8 over 3. The right-hand side does not equal the left-hand side, so I can actually cross out x equals negative 1/3 because that solution was extraneous. So next, we're going to test out our solution x equals 5. So absolute value of 5 plus 3 is equal to 2 times 5 minus 2. So I'm going to get 8 is equal to 10 minus 2. So 8 equals 8. That does work out. So my only solution is x is equal to 5. Let's go ahead and look at example 3. I have x to the 4th minus 5x squared is equal to negative 6. So the first thing I want to do is move that 6 over, so I have everything equal to 0. So I have x to the 4th minus 5x squared plus 6 is equal to 0. Okay, now I have x to the 4th and x squared, so I'm going to use some substitution. I'm going to say that x squared is equal to y, and I'm going to use this to factor. So if I substitute that, now I have y squared minus 5y plus 6 equals 0, and that's a little bit easier for us to factor. So I'm going to have y minus 3 times y minus 2 is equal to 0. So now, once I'm here, I'm actually going to substitute back to get our answers. So I have x squared minus 3 equals 0, and then x squared minus 2 equals 0. So I have x squared is equal to positive 3. So x is going to equal plus or minus the square root of 3, because I took the square root of both sides. Then I have x squared is equal to positive 2, take the square root of both sides, and x is going to equal to plus or minus the square root of 2. So I'm going to write my final answer. X is equal plus or minus root 3, comma, plus or minus root 2. Okay, I don't need to check for extraneous because I did not square both sides and I did not multiply both sides by a variable. Okay, moving on to example 4, we have 8t raised to the negative second power minus 17t raised to the negative first power plus 2 equals 0. So this one doesn't look very nice, so we are going to use some substitution to help us out a little bit. So we are going to let x equal t to the negative first power. And then just remember that t to the negative first power is the same thing as 1 over t. Okay, so if I rewrite this, I'm going to have 8x squared minus 17x plus 2 equals 0. Now I can go ahead and see if this is factorable. So I have 8x minus 1, x minus 2 is equal to 0. Okay, if you need a little reminder, you can always check your inners and outers. So I would have negative 1x, negative 16x, negative 17x. That does equal my middle term, so I know I factored it correctly. All right, so once we are here, I'm going to substitute back. So I'm going to have 8t to the negative first power is equal to 1. And then I'm going to have t to the negative first power is equal to 2. So then I am going to have t to the negative first is equal to 1/8. So t is equal to 8. And t is equal to 1/2. Okay, you can always just substitute these values back in to double check that you did it correctly. Just use your calculator, type in 8 parentheses 8 raised to the negative 2 power minus 17 times 8 raised to the negative first power plus 2, and that should give you 0. Same thing for 1/2. Okay, looking at example 5, we have t to the 6th plus 4t to the 3rd plus 2 equals 0. So we have exponents raised to large powers. So let's think what can make that a little bit easier for us. So we can let x equal t to the 3rd power. That would have us working with x squared and x. So I'm going to have x squared plus 4x plus 2 equals 0. Okay, the problem here is that this is not factorable. So if something is not factorable, we're going to have to use the quadratic formula. Okay, so we are going to have x equals negative 4 plus or minus 4 squared is 16 minus 4 times a times c divided by 2 times a, which is going to give us 2. So I have x is equal to negative 4 plus or minus the square root of 8 all over 2. So we have x is equal to negative 4 plus or minus 2 root 2 all over 2. And last step, x is equal to negative 2 plus or minus the square root of 2. Right? But now we have to substitute back in. So we had that x was equal t to the 3rd power. So I have t cubed is equal to negative 2 plus or minus the square root of 2. So now I have to take the cubed root of both sides. So I'm going to have t is equal to the cube root of negative 2 plus or minus the square root of 2. Okay, you should test this. So using your calculator, I would store the cube root of negative 2 plus the square root of 2 in for x. Substitute that into our original equation. Make sure that it equals 0. and then do the same thing for the cube root of negative 2 minus the square root of 2.
Okay, so I'm just going to show you how to store something into your calculator so that we can check for the extraneous solutions. So go to math, go down to the fourth option, then we had negative 2 plus the square root of 2, make sure that you arrow out, store that as x, then we can go ahead and substitute that in. So we had t to the 6th plus 4t to the 3rd plus 2, so I'm going to use x to the 6th plus 4x to the 3rd plus 2, and that does equal 0. Okay, then you can go ahead and do the exact same thing with negative 2 minus the square root of 2 plus x. Okay, or you can use your second entry to get back here. Just arrow back, change this to a minus, arrow out, enter. Okay, I'm going to do the same thing, second entry, one more time, second entry. Now my x is stored as my second solution. Okay, so we get negative 1 e to the negative 12th. So that is not 0, but it is very, very, very close to 0, so it is a solution. So we are good to go.
All right, so number 6, this is our last example for today's notes. So we have x minus the square root of 3 minus x equals negative 3. So I do want to get my square root isolated, so I am just going to rewrite this as x plus 3 is equal to the square root of 3 minus x. Okay, then I am going to square both sides. So since I'm squaring both sides, I'm going to make a note to check for an extraneous solution at the end. Okay, so if I square both sides, I have x squared plus 6x plus 9 is equal to 3 minus x. Let's move everything over to one side so it's equal to 0. So I'm going to have x squared plus 7x plus 6 is equal to 0. We can factor this, so I have x plus 1 times x plus 6 is equal to 0. So x equals negative 1 or negative 6. But let's just make sure and check for our extraneous solutions. So we're going to substitute back into the original problem. So if I do that, I have negative 1 minus the square root of 3 minus a negative 1, and that should equal negative 3. So I'm going to have negative 1 minus square root of 4 equals negative 3, so I have negative 1 minus 2 equals negative 3. Negative 3 equals negative 3. So we do know that negative 1 is a solution. Let's do the same thing with negative 6. Okay, so I'm going to have negative 6 minus the square root. 3 minus a negative 6 would just give us plus 6 is equal to negative 3. So I have negative 6 minus the square root of 9 equals negative 3. Negative 6 minus 3 is negative 3. Negative 9 does not equal negative 3. Okay, so then I'm going to cross off my negative 6, and my only solution is x is equal to negative 1.